Hey everybody, and welcome back to another video. Today we're going to be doing a test between the difference of the means for a dependent sample. And everything, we're going to kick off chapter 11 with this video. And, chapter 10 that is. And everything that we do in chapter 10 is basically the same thing as we do in chapter 9. Besides some tweaks in the formulas, the steps are exactly the same. So if you're feeling pretty confident with chapter 9, then chapter 10 is not going to be an issue for you. So let's get started. So right away, let's just get familiar with the formulas that you're going to need to know. It's basically the same. Instead of having x bar minus mu, we have the difference, the average of the difference of the means as d bar over the sample standard deviation over root n. And we're always going to use a t-statistic because we're always going to have a sample standard deviation. Okay, so that's about it as far as the formula changes for this part. So let's just dive right into it. In a study comparing banks in two countries, a sample of 142 matched pairs of banks was formed. Each pair contained one bank from country X and one from country Y. The pairings were made in such a way that the two members were as similar as possible in regards to such factors as size and age. The ratio of total loans outstanding to total assets was calculated for each of the banks. For this ratio, the sample mean difference between country X and country Y was 0.0529, and the sample standard deviation of the difference was 0.3058. So again, you can see how this is already shaping up to be like the other problems in chapter 9. We're going to get a t-statistic. We're going to find our t-critical threshold. We're going to find where our t-statistic lies on that distribution and whether or not that indicates that we should perhaps reject the null and assume that so something different takes that place. So all the numbers in this equation, all the variables are pretty much given to us right away. 142 matched pairs, that's going to be our sample size. X minus Y, the difference between X minus Y, that's obviously d bar. And the sample standard deviation, which we denote as SD. And again, just like it's always been, we plug them in, we get our t-statistic of 2.061. And we're going to find out where that lies on the distribution and see if we should reject our null hypothesis or not. That is, of course, the two-tailed in this case. And as I'm not going to go over the cases because we've done it plenty of times, but as we know, this is case 3, whether it can be greater than t critical threshold or less than the negative t critical threshold. So just to change things up a little bit, I decided to show you guys just how to find the t-score for this test. It's a 1% test, two tails, so the 1% divided by 2, it's 0.5%. And we have 142 minus 1 is 141 degrees of freedom. Obviously, it's not shown on the t-table, so we have to approximate. It's definitely closer to 100 than it is to 1,000, so we can go around 2.62. In my case, I just picked 2.61, which is just slightly smaller because it's a larger degrees of freedom. And so yeah, that's as simple as that. We've plotted everything on our distribution. 0.5% in each rejection region. We have our critical thresholds of 2.61, which we just found on our t-score table. Our critical value, our t-critical value, 2.061, obviously falls in between the region, and as we know, we've said it many times before, this is a do not reject, and that's about as hard as that question's ever going to get for you. We'll have about 4 more videos coming up for this chapter, independent samples, in which case you'll be doing -2 degrees of freedom for each group when you're testing the difference. In this case, for dependent samples, it's only n-1. And that's about it. Thanks again for watching, and I'll see you in another video.